So, welcome back, my dear friends. We were discussing permutations and combinations, right? Today in this session, let us try to wind up the concept of permutations. Now, before starting with permutations, we were discussing two rules, addition rule and multiplication rule, right? I said you, if two or more things are connected with the word or, you will be using addition rule. If two or more things are connected with the word and, you will be using multiplication rule. Okay. Next step. Then we have discussed the factorial. What is factorial? A simple backward multiplication is called as factorial. How will you write n factorial? N into n minus 1 into n minus 2, so on till n minus, so on till 1, right? Next step. Or you can even write it as n into n minus 1 factorial. Next, after this, we have started with permutations. Permutations is nothing but you are doing arrangements. So whenever you are doing arrangements, my dear friends, remember that order is important. Order is important. However, in examinations, in many cases, the question itself says whether it's permutations or combinations. However, if a number is given or if a word is given, then it's a deemed assumption that it's a permutation. If selection or committee formation is given, it's a combination, right? Next step. Number of ways of arranging R things from N things. We understood that it is NPR. What are the restrictions on NPR? N should be greater than or equals to R, and N and R both must be positive integers, right? How will you write NPR? N multiplied backwards R times. Or what is the formula? N factorial divided by N minus R factorial. Now remember this, NPR, it has R factors. Okay, like 5p3 is there. How will you write 5p3? 5 into 4 into 3. Okay, so it has 3 factors. Okay, how will you write 5 into 5 into 4? 2 factors. So NPR has R factors. Formula will be N into N minus 1 into N minus 2, so on till N minus R plus 1. Next, NP1 we have discussed that it is 1. NP2 is N into N minus 1. NP3 is N into N minus 1 by 2. Sorry, N into N minus 1 into N minus 2. Next, NPR can also be written as N into N minus 1p R minus 1. Like I am having 7p4. 7p4 can also be written as 7 into 6p3. Both you will get the same answer. Okay. They are just a alternative mode of presentation. That's it. 1 minute. Now, next. So till here we have done in our last session, my dear friends. Now let's proceed further. Let's proceed to few examples. Okay. Now, first one. I'm telling 5 students are there. You need to arrange them in 5 places. Now, how will you arrange 5 students in 5 places? 5 things can be arranged in 5 places. 5 things can be arranged in 5 places in 5p5 ways. Right? Next, 5p5 can also be written as 5 factorial. Okay. Next. I'm taking a word called as computer. Let us see so many possibilities for this one word computer. First possibility, point number A. How many arrangements are possible for the word computer? Now, how many letters are there in the word computer? 1, 2, 3, 4, 5, 6, 7, 8 letters are there. When I am telling there are arrangements for a word, what happens is that the letters in the word come outside. 1, 2, 3, 4, 5, 6, 7, 8. In the word computer, you are having 8 letters. All the 8 letters will come outside and they will arrange themselves in the 8 places. Now, how will you arrange 8 things in 8 places, sir? Obviously, 8 factorial ways. 8 things can be arranged in 8 places in 8p8 ways. That is 8 factorial ways. I hope the point is clear. Next, point number B, rearrangements. Now, what do you mean by rearrangements? Rearrangements means the same word should not come again. When the same thing should not come again, I will remove that one possibilities. So, rearrangements will be 8 factorial minus 1. Okay. I hope that's fine. Arrangements means 8 factorial. Rearrangements means total arrangements minus 1. Okay. Now, next point number C. I am telling how many arrangements are possible such that vowels are together. Vowels are together. Now, how you will do this? Vowels are together. In the word computer, how many vowels are there? Let's check. O is the vowel. U is the vowel. E is the vowel. What are the consonants? What you have? C, M, P, T, R. These are the consonants. These are the vowels we have. These are the consonants we have. Okay. Now, he's telling vowels are together. Whenever some things are together, what you will do, you will merge them into one thing and then you will do the arrangements. Now, what I'm doing, O, U, E, since he's telling vowels are together, I'll tie them tightly together. I'm tying them. They can't move. So, 1. So, 1, 2, 3, 4, 5, 6. How will you arrange 6 things in 6 places? 6 factorial. Now he is telling vowels are together, but he didn't tell in which position they are together. So can I say O, U, E, 3 can interchange among themselves? Yes, sir. How will they interchange among themselves? They will come outside first and then they'll interchange. 3 things interchanging among themselves will be 3 factorial ways. So I hope first 3 concepts are together. Arrangements, all the 8 letters will come outside and arrange themselves in 8 factorial ways. Rearrangements, they'll come outside, they'll arrange. But he's rearrange. The word computer should not come again. So -1. Vowels are together. O, U, E, you packed them together. You made them into one strong unit. However, inside that they can interchange among themselves. There is no issue. Next, point number D. Consonants are together. Consonants are together. So what do you do? Again, same. O, U, E, C, M, P, T, R. Consonants are together. You will go ahead and you will tie the consonant tightly. So you will make them into one single unit. So 1, 2, 3, 4. 4 things you can arrange in 4 factorial ways. C, M, P, T, R. They can interchange among themselves? Yes. They are together, but still they can rearrange among themselves. 5 things can be rearranged among themselves in 5 factorial ways. Okay. Next. Point number E. No 2 vowels are together. No 2 vowels are together. Now, when he's telling no 2 things are together, what you'll do is you'll do alternative arrangements. Alternative arrangements. Now, what do you mean by alternative arrangements? He's telling no 2 vowels are together. I hope you remember in your childhood when they used to say no 2 boys are together. What they used to do? All the girls, they used to make them sit alternatively, right? Same way here also. No 2 vowels are together. First, arrange the consonants. C, M, P, T, R. How will you arrange 5 consonants in 5 places? Obviously, sir, 5 factorial. In between them, how many gaps are there? 1, 2, 3, 4, 5, 6. In these 6 gaps, I will arrange 3 vowels in 6P3 ways. So when I am telling no 2 vowels are together, first I'll arrange consonants. In between the consonants, I'll arrange the vowels. Next. Point number D. Consonants are never together. Consonants are never together. Whenever he is telling consonants are never together, whenever he is using never together, see here, be careful. They are 2 different things. Here, no 2 things are together. Here, never together. Okay. Whenever he is telling never together, what you'll do is that you'll do total arrangements. You'll do total arrangements minus always together. You'll do simply total arrangements minus always together. Now, what are total arrangements? What we have? Total arrangements we already calculated. It is 8 factorial. Minus consonants always together. What are consonants always together? 4 factorial into 5 factorial. Sir, can't we do alternative arrangements? Yes, we can do alternative arrangements also. That's also fine. But in this question, it is not possible. If you can get alternative arrangements, go ahead and do that. Nobody is going to stop you. But unfortunately, in this question, alternate arrangements are not possible. Since alternate arrangements are not possible in this question, I'm not doing it. Okay, if it is possible, I would have done that only. Okay. Next, point number G. Starts with C. How many arrangements are there such that it will start with C? Now, my dear friends, in the word computer, how many letters we have? COMPUTER. 8 letters we have. He's telling it will start with C. 4, 5, 6, 7, 8. I'll take this C and I'll place here. How will I place one letter in one place? 1, P1. Now, how many letters we have? 1, 2, 3, 4, 5, 6. 7 you have. How will you place 7 letters in 7 places? 7P7, which is equals to 7 factorial. Okay. Next. Starts with C and ends with R. Starts with C and ends with R. 1, 2, 3, 4, 5, 6, 7, 8. He's telling it will start with C and it will end with R. Take this C and place here. Take this R and place here. So how many letters we have? 4, 5. How will you place 5 letters in 5 places? 5 or 6? 1, 2, 3, 4, 5, 6. How will you place 6 letters in 6 places? 6 factorial. Okay. Starts with C and ends with R. Next. 5. Has C and R in end places. Now, what do you mean by has C and R in the end places? Basically, it is the same thing. But he is telling C and R will be in the end places. Means C and R you can interchange among themselves. How will you interchange two things among themselves, my dear friends? C and R. Two things can be interchanged among themselves in 2 factorials. So, 5 like this is telling C and R in end places. Means either it can start with C and end with R, or it can start with R and end with C. Any possibility is fine. There is no issue. Okay. So I hope all these possibilities are clear. Next. J. The word pewter is always present. The word pewter is always present. How many possibilities are there for the word computer? So the word pewter is always present. COMPUTER. He is telling the word pewter is always present. So go ahead and merge this into one thing. Okay. So that it won't interchange among itself. Join them. 1, 2, 3, 4. 4 things can interchange among themselves in 4 factorial ways. Now again, pewter will you interchange among itself? No, don't interchange among itself. Pewter. Okay. Why you won't interchange pewter among itself? Simple, sir. Why you interchange it? It's telling the word pewter is always present. So unfortunately, you can't interchange among itself. Okay. So I hope all these points related to this word computer is clear. So total 10 permutations we have seen. 10 different cases we have seen. A single word computer. And I hope all the concepts related to word computer is clear. So any doubt any of you in these 10 concepts? Yogita, Geeta, Vaishnavi, or let's proceed to the next concept. Next example. E. No two vowels are together. E or F, that is F. Consonants are never together, he is telling. Consonants are never together means first you will do total arrangements minus always together. Like I am telling how many boys are there in the class. I'll do total strength minus girls. If I do total strength minus girls, I'll get boys, right? The same way, consonants are never together. I'll do total arrangements minus always together. What are total arrangements? 8 factorial. What are consonants always together? 4 factorial to 5 factorial. Instead of total arrangements, I'll remove always together possibility, right? So from total arrangements, I'll remove always together. I'll get never together. Okay. So I have Geeta, that's fine. Sure. Let's go for the next one. Okay, next example. Example number 3. Okay. Now, I am having 5 letters. 3, 4, 5, 6, and 7. I'm having 5 letters, 3, 4, 5, 6, 7. So I need to form a 5-digit number. 5-digit number. I'm having 5 numbers, 3, 4, 5, 6, 7. I need to form a 5-digit number. How will you form a 5-digit number with 5 numbers? Obviously, it's a 5-digit number. 1, 2, 3, 4, 5. How will you arrange 5 digits in 5 places? 5 factorial. Next point number B. Form a 5-digit number divisible by 5, I am telling. Form a 5-digit number which is divisible by 5. 1, 2, 3, 4, 5. Now what I'll do, I'll remove this 5 from here and I'll place here. How will you place one number in one place? 1P1. Don't say 5 will be kept in last place in 5P1 place. No. The one number will be kept in one place in 5P1 place. He's telling it should be divisible by 5, right? 5-digit number which is divisible by 5. Next, this is over. Now 4 letters are left. How will you keep in 4 places? 4P4 which is simply equals to 24. Next, 5-digit even number. 5-digit even number. Now try to understand. 3, 4, 5, 6, 7. Total 5 numbers are there, right? I need to form a 5-digit even number. What I'll do, I'll take this even numbers. 2 even numbers are there. From this, any one even number I'll place here. So from 5 numbers, one number has taken its position. So how many numbers are left? 4 numbers are left. 4 numbers can be kept in 4 places in 4P4 ways. So answer is 4 factorial into 2. 5-digit even number. First, I'm taking 4, 6, 2 even numbers are there. One number I'll take from them in 2P1 ways and I'll place them. So from 5 numbers, one number is over. How many are there? 4 numbers are. 4 numbers can be kept in 4 places in 4P4 ways. Simple. Next. 5-digit odd number. 1, 2, 3, 4, 5. 5-digit odd number. Now, how many odd numbers we have? 1, 2, 3 odd numbers we have. One odd number I'll place here in 3P1 ways. So from 5 odd numbers, one number is completed. 4 numbers are left. 4 numbers can be kept in these 4 places in 4P4 ways. So 4 factorial into 3. Next. 5-digit number greater than 5,000. 5-digit number greater than 5,000. I'm asking, please get a 5-digit number which is greater than 5,000. How will you get a 5-digit number greater than 5,000? 1, 2, 3, 4. Sir, every 5-digit number is greater than 5,000. Okay, greater than 50,000, sir, not 5,000. 5-digit number greater than 50,000. Please tell me a 5-digit number greater than 50,000. When I am telling 5-digit number greater than 50,000, my dear friends, think and tell 3, 4, 5, 6, 7. I am telling it should be greater than 50,000. Can you keep 3 and 4 in the first place? Obviously, no. To keep 3 and 4 in the first place, obviously it will be less than 50,000. Can I keep 5, 6, 7 in the first place? Yes. From 3 numbers, any one number can be kept in first place. So from 5 numbers, one number has taken its position. So 4 numbers are left. 4 numbers can be kept in 4 places in 4p4. So answer is 3 into 4, 5. Okay. So I hope that's fine, everybody. All the 5 cases. Please check it. Geeta, Vaishnavi, Yogita, once go through this and see if the 5 cases are clear or not. Fine, Yogita. What about you, Vaishnavi and Geeta? Shall we proceed? Yes, sir. Let's proceed. So Vaishnavi and Geeta, I hope there is no issue with these 5 different cases. The 3 examples we have done, and I hope all 3 examples are fine. Next, 4th example. Fourth example. Now, I'm having numbers 0, 1, 2, 3, 4. Okay. 0, 1, 2, 3, 4. These are the numbers what I'm having with me. Okay. I need to form 4-digit number. I need to form 5-digit number. Now see here, how will I? I'm having numbers 0, 1, 2, 3, 4. I need to form a 4-digit number. I need to form a 5-digit number. 4-digit number. Can you keep 0 in the first place? 5 numbers are there. In these 5 numbers, can you keep 0 in the first place? Obviously, no. Because if you keep 0 in the first place, it will not become 4-digit number. Rather, it will become 3-digit number. So, other than 0, what are the numbers what we have? 4 numbers I have. Any one number I can place here. How will I place? I'll place in 4p1. So, from 5 numbers, one number has taken its position. 4 numbers are 4 numbers can be arranged in 3 places in 4p3. So answer is 4 into 24, which is equals to 96. So don't want to do this entire process, you have a formula also. Okay. The number of ways of arranging numbers when 0 is there. But I'm telling, the number of ways of arranging numbers when 0 is there is NPR minus n minus 1p r minus 1. This is the formula what I use. 5 numbers are there in our case. I need to form a 4-digit number. 5p4 minus 4p3. 120 minus 24, which is equals to 96. Okay. Once again, listen the logic. 5-digit number. Can you keep 0 in the first place? Unfortunately, no. 0 cannot be kept in the first place. 1, 2, 3, 4. From 4 numbers, any one number can be kept in the first place. 4p1. Now, My dear friends, from 5 numbers, 1 number is completed. So how many numbers are left? 4 numbers. How will you keep 4 numbers in 4 places? 4p4. 4 into 24, which is equals to 96. Okay. If you want, you can use the formula also. There is no issue. It will be 5p5 minus 4p4. Okay. Answer will be same, however, 96. Okay. So I hope all three of you, case 4 is clear. Fourth example is clear. Any issue in fourth example? No, right? Shall we proceed further? There is no issue in fourth example. Yes, sir. Perfect. Next example. Example number 5. Now see here, example number 5. I'm having 5 books on Sanskrit. 5 books on Sanskrit. Next, 3 books on English. 3 books on Hindi. Now, first case. I'm telling all subjects books are together. All subjects books are together. All subjects books are together. When I'm telling all subject books are together, how will you form it? 5 books of Sanskrit, I'll make into 1 unit. 3 books of English, I'll make them 1 unit. 3 books on Hindi, I'll make them 1 unit. Okay. So how many units you are having? 1, 2, 3 units. How can you arrange 3 units in 3 places? 3 factorial units. Can 5 books of Sanskrit be interchanged among themselves? Yes, sir. He's telling that together, but he didn't tell in which position they are. So 5 factorial. 3 books on English? Yes, sir. 3 books on Hindi? Yes, sir. You can interchange among themselves. So answer is 3 factorial into 5 factorial into 3 factorial into 3. Next. No 2 books on Sanskrit are together. No 2 books on Sanskrit are together. So first what I'll do, I'll arrange 3 English books, 3 Hindi books. So how will you arrange 6 things in 6 places? 6 factorial ways. In between them, how many gaps are there? 1, 2, 3, 4, 5, 6, 7 gaps are there. In these 7 gaps, I need to arrange the 5 Sanskrit books. So 7, P, 5, this. Okay. Next, point number 3. Sanskrit books are together. Sanskrit books are together. Okay. Case 1, he said all the 3 books are together. But now he is telling Sanskrit books are together. So what you will do, my dear friends, you will go ahead and you will take this Sanskrit books as 1 unit. 3 books on English, 3 books on Hindi. So 1, 4, 8. 1, 4, 7. 7 factorial. Can you re-interchange 5 Sanskrit books among themselves? Yes. 5 factorial. Okay. So I hope all these 5 examples are clear, my dear friends, on permutations. Simple, all concepts I have covered in these 5 examples. You can take up any sum after this. You will be in a position to do it, based whether if there is no repetition provided. Now, 10 persons arranging in a row. How will you do n persons arranging in a row? N factorial. Next, number of r-digited numbers from n digits. If there is no 0, NPR. If there is 0, NPR minus n minus 1p r minus. Next, case 7. Sum of n digits from r digits. How will we do this? See, Very rarely they'll ask this question. So you need to remember the formula. You need not remember the method. Okay. Why you need not remember the method? So simple. Method is very lengthy. Formula also, I guess in 2008, it was the last question where he asked. After 2008, never he asked a question on this. Okay. So see here, I'll explain you the formula, point number 7. Point number 7. No, one more point. Example number 6. Example number 6. Now, I'm asking sum of all 4-digit numbers with digits 2, 4, 6, 8. Sum of all 4-digit numbers with digits 2, 4, 6, 8. Now, how will you do this? It's quite simple. We'll use the formula. Formula is n minus 1 p r minus 1 into 1, 1, 1, 1, so on r times into sum of numbers. This is the formula what we use. 4-digit number from 4 digits. N is equals to 4, R is also equals to 4. So 4 minus 1, P 4 minus 1. 1, 2, 3, 4 into 2 plus 4 plus 6 plus 8. Just straightforward, you need to remember the formula. It's not that important for examination, however. 1, 1, 1 into 20. What is 3 factorial? 6 into 1, 1, 1, 1 into 20. So answer is 1,33,320. Okay. So sum of all distant numbers, which is 2, 4, 6, 8, is 1,33,320. This formula you remember, process is not required, and with the 0 is also not required, because with the 0 is never asked in the examination till in the past 20 to 30 years. Never they have asked with 0. Okay. So without 0, you can remember, that's more than enough. If you think that if your fate is very bad and he may ask in your exam, you can remember that also. Formula. Also simple. Only little change in the formula. That's it. Now, next example. Example number 7. This example number 7 is related to this point. Yeah. N articles are arranged in such a way that 2 particular articles never come together. N minus 2 into n minus 1 factorial. Okay. So what is this? See here. Example. I'm telling that there are total 10 examination papers. 10 exam papers. In these 10 examination papers, you are having one best paper, one worst paper, and I'm telling you are having 8 normal papers. I am asking arrange in such a way that best and worst never come together. Okay. You can do either alternative arrangements or you can do total possibilities minus always together. That will also give the same answer, but better to do alternative arrangements. Okay, because it is possible, right? Therefore, consonants never together, it was not possible, so I haven't done that. It is possible to do alternative arrangements. He's telling 10 examination papers are there. In these 10 examination papers, one is best paper, one is worst paper, and 8 are normal papers. This is the question. Arrange in such a way that best and worst never come together. So what I'll do is that first I'll arrange the 8 normal papers. 1, 2, 3, 4, 5, 6, 7, 8. How will you arrange 8 papers in 8 places? I'll arrange in 8p 8 ways. Okay. In between them, how many gaps are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 gaps are there. In these 9 gaps, I'll arrange one best paper and one worst paper in 9p2 ways. Okay. First 8 normal papers can be arranged in 8 ways in 8 factorial ways. One best and one worst paper can be arranged in this 9 gaps in 9p2 ways. Now what is 8p8? Obviously 8 factorial. 9p2 can I write it as 9 into 8? Yes, sir. Remember 8p8, I am writing it as 8 factorial. 9p2, I am writing it as 9 into 8. Do you remember, my dear friends? I said you n factorial is n into n minus 1 factorial. So can I write 9 factorial as 9 into 8 factorial? Yes, sir, you can write. So 9 into 8 factorial, I'm writing it as 9 factorial into 8. Okay. Now, here 10 you have. When 10 you are having, you are writing 9 factorial into 8, right? If you are having n instead of 10, you are having n instead of 10, how will you write? You will write it as n minus 1 factorial into n minus 2. I hope all of you will agree this. 10 is there, you wrote 9 factorial into 8. If n is there, how will you write? You'll write n minus 1 factorial into n minus 2. That's how you write it. Okay. So that's how I got this n minus 1 factorial into n minus 2. It's an important. Okay. So any issue is there in this example 7? Any of you? No issue. Which method, Vaishnavi, you are telling? Always together? The total possibilities minus always together. That one you are telling? Okay. That also you can do. Total possibilities minus always together. Now 10 papers are there. How will you arrange them? 10 factorial minus. He is telling best and worst are together. So best and worst, I'll assume them as 1 unit. So 8 units, 1 unit, 9 units. Can best and worst interchange among themselves? Yes, they can interchange among themselves with 2 factorials. Okay. You can check 9 factor into 8 and this one both will give you the same answer. And there is no change. Let me check. Both of the answers will give 29 lakh 3,040. Here also you will get 29 lakh 3,040. Here also you will get 29 lakh 3,040. But however, in the examination, no, you will find this one. Okay, this will not be there. The answer is same. We have to be careful. Okay, so better to do in this method only instead of second method. I hope Vaishnavi, that's fine. Answer will be same however in both the places, but go for this first method only instead of second method. Next. Now, in the sums, what we have seen just now, there was no repetition in the words. Like you take computer, you take triangle, you take domestic. In all these cases, what happens? There is no repetitions. You take daughter, domestic, computer, violence, okay, and still triangle. In all these words, you see, my dear friend, there is no repetition in letters. But if there is a repetition in letters, how are we supposed to do? Okay, like say for example, I am telling how many arrangements are possible for the word. Let me take here. I'm having the word interference. Interference. I'm asking how many arrangements are possible for the word interference. Now, my dear friends, when you're having a words like this and when there repetition in letters, you will go ahead and you will cancel the repetitions. Like say for example, there's a person who's telling this word and this word, both are different. It's telling first word and second word both are different. Sir, how come they are different? First word is moon, second word is also moon. How can they both be different? No, I'm telling O and O is there. No, I have interchanged these two O's. First O I have written here, second O I have written here. So these both are different. And what nonsense is this? Even if you interchange also, they will be same. That's the reason whenever there are repetitions, you will divide by number of repetitions. Okay. Now in the word interference, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 factorial. Whole divided by. What is repeated? N is repeated 2 times. 1, 2. N is repeated 2 times. 2 factorial. Next E. 1, 2, 3, 4. E is repeated 4 times. 4 factorial. Next R. 1, 2. R is repeated 2 times. So 2 factorial. Okay, you'll simply go ahead and you'll divide by number of repetitions. If there is any repetition in a word, you simply go ahead and divide by number of repetitions to get the number of arrangements. Now, next point number B. Can you tell me Haryana? Haryana. What will be for Haryana? 1, 2, 3, 4, 5, 6, 7. 7 factorial whole divided by 1, 2, 3. A is repeated 3 times, 3 factorial. That's it. 7 factorial by 3 factorial. Simple. We'll simply go ahead and divide by number of repetitions. Next point number C. Think and tell. This you will only tell me. Assassination. You need not type the factorial. Factorial option is there. No, you can type factorial also. Assassination. Next, permutation. Assassination, permutation. Can you tell me for assassination, permutation? Yeah, simple. Okay, assassination, let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 factorial divided by A. 1, 2, 3. A is repeated 3 times. S. 1, 2, 3, 4. 4 times. Next I. 1, 2. 2 times. Next N. 1, 2. 2 times. What about permutation? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 factorial whole divided by T is repeated 2 times. Still any repetitions are there? That's it. Yes, sir, that's it. 11 factorial by 2 factorial. So I hope it's clear, everybody, how to solve if repetitions are there. You will simply go ahead and you will simply divide the number of repetitions. Let me check. Number of arrangements. If there are repetitions in given things, n factorial divided by this, where ABC refers to repetition. Like accountant is there, 10 factorial by 2 factorial, 2 factorial, 2 factorial, and 2 factorial. Okay. So I hope this point is also clear. Now, let me give you one question, my dear friends. This is example number 8. Let me give you one question, example number 9. Solve it and tell me the answers. Okay. Example number 9. I am having the word arrange. Where is this word arrange? Arrange, arrange, arrange. First, point A. Number of permutations. Next, point B. Two R's together. I want how many possibilities are there. Next, two R's not together. How many possibilities are there? Point number D. Two R's and two A's are together. How many possibilities are there? Next, vowels are always together. Five questions. I'll give you 3 minutes. Please go ahead, solve and tell me. Okay. Arrange. How many permutations are possible? How many possibilities are two R's are together, two R's are not together, two R's and two A's are together, vowels are always together. Okay, let us look into the answers. Yes, sir, let us look into the answers. First, number of permutations. How many letters are there? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 factorial. A is repeated 2 times. R is repeated 2 times. Okay. Two R's are together. R and R is together. Pack them. A, N, G, T. 1, 2, 3, 4, 5, 6. 6 factorial. Since A is repeated 2 times, divided by 2 factorial. Now don't say, sir, R I can interchange among themselves. I'll multiply with 2 factorial. Nonsense. If R is interchanged among themselves, there is no point in multiplying with 2 factorial. These are 7 letters are there in the word arrange. A, R, R, A, N, G, E. So 7 factorial by 2 factorial to 2 factorial. First one. Next one, 2 R's together. So you join 2 R's together. 1, 2, 3, 4, 5, 6. 6 factorial. Since A is repeated 2 times, I'm dividing by 2 factorial. Next, 2 R's, 2 A's together. 1 unit. 2 A's, 1 unit. NGE. 1, 2, 3, 4, 5. 5 factorial. R and R cannot interchange. A and A cannot interchange. Okay. 2 R's not together. 2 R's not together. So A, N, G, E. 5 things can be arranged in 5 factorial ways. In between them, 1, 2, 3, 4, 5, 6. 2 R's can be arranged in 6p2 ways. Since A is repeated 2 times, 2 factorial, R is repeated 2 times, 2 factorial. Understand this point number C once again. 2 R's are not together. So A, N, G, E. 5 things I'll arrange in 5 factorial ways. In between them, how many gaps are there? 6 gaps are there. In these 6 gaps, I'll arrange the 2 R's in 6p2 ways. Now A is repeated 2 times, so divide by 2 factorial. R is repeated 2 times, so divide by 2 factorial. Next, vowels are together. What are the vowels here? A, E. R, N, G. All vowels, tie them together. So 1, 2, 3, 4, 5. 5 things, 5 factorial. 3 vowels can interchange among themselves in 3 factorial. Since R is repeated 2 times, A is repeated 2 times, you simply divide by 2 factorial and 2 factorial. Okay. So I hope example 9 is clear. Any issues there? Example 9, all 3 of you. Gita, Vaishnavi, and Yogita, please check your answers. Point D. 2 R's and 2 A's together. So 2 R you will take it as 1 unit. 2 A's you will take it as 1 unit. So 1, 2, 3, 4, 5. 5 things can be interchanged in 5 factorial ways. Okay. See, there is no interpretation now again. Okay. R's cannot, you will not divide them by 2 factorial by 2 factorial because you merged them together. Okay. So I have Vaishnavi, point D is clear. Okay, you are telling RR and AA you will interchange, Gita. Okay, RR you interchange 2 factorial. AA you will interchange 2 factorial, right? But since R is repeated 2 times, A is repeated 2 times, they both will get cancelled again. So even if you interchange, since they are repeated, you have to divide by number of repetitions, no? They'll get cancelled eventually. I hope that's fine, Gita, point number D. And I hope Vaishnavi, for you also point number D is fine. Fine, then let's proceed further. The next word. This is clear. There is one word which I want you to solve. Don't worry, after that I'll give you a break. We'll have a 10 minutes break because I know it's a little hectic. Then again we'll continue the class. Example number 10. I am having the word Haryana. Okay. Point number A. Number of permutations. Next point number B. H comma N are together. Next point number C. Starts with H and ends with N. Next, consonants are together. Last question. After this, you can take a break. Number of permutations H and N are together. Starts with H and ends with N. Consonants are together. Okay, let's check the answers. Number of permutations for Haryana already we have done. 7 factorial by 3 factorial. 7 factorial by 3 factorial. Next is telling H and N are together. H N A R Y A A. H and N are together. Join it to one unit. So 1, 2, 3, 4, 5, 6. 6 factorial. H and N can interchange among themselves. A is repeated 3 times. Starts with N and H with ends with A. Take this H, place here. Take this N and place here. Now, how many letters we have? 1, 2, 3, 4, 5. 5 factorial divided by 3 factorial because A can interchange among themselves. Consonants are together. H, R, Y, N, A. Consonants are together. Merge them together. One unit. 1, 2, 3, 4. 4 factorial into Four consonants can interchange among themselves in 4 factorial ways. A is repeated 3 times, so 3 factorial. So I hope that's fine, all 4 of you, or all 3 of you. Perfect Geeta, perfect Yogita. So I hope Vaishnavi you got all correct. So it's 6:16. We'll resume at 6:30. Now let's continue after break, my dear friends. So 10 examples we have done. Now let's go for the 11th example. Okay. Now 7 persons are there. These are row arrangements. Row arrangements. Now see this row arrangement. What happened to this? Where did it go? Please look into this row arrangements. Point number A. I am telling total 7 persons are there. 3 sit in a particular order. Particular order. I'm telling 7 persons are there and 3 people sit in a particular order. How will we do this? Simple. Row arrangements in 7 places. So 1, 2, 3, 4, 5, 6, 7. Okay. He is telling 3 people sit in a particular order. Join them together. Join them tightly. Now, how many units are there? 1, 2, 3, 4, 5. How will you arrange 5 units in 5 places? 5 factorial. Sir, can I interchange these 3 people among themselves? No, you can't interchange. Because he's telling 3 people sit in a particular order. Okay. Sir, what if it is like this? 3 sit together. When he is telling 3 sit together, then you can do 5 factorial into 3 people interchange among themselves 3 factorial. Okay. So I hope you understood the difference. Particular order and sit together. Particular order means they cannot interchange among themselves. Okay. Now 3 sit together. You can sit together and they can interchange among themselves. There is no issue. Point number B. Next. Now, you know what answer you have in ICM material for this? 5 factorial into 3 factorial, right? 3 factorial, can I write it as 6? Yes, sir. What is 6 into 5 factorial? 6 factorial. This option you have in your ICM material for this. You don't have 5 factorial to 3 factorial, rather you have 6 factorial as answer. That's a very good book that is. Next step. He's telling 7 persons, 2 people occupy n seats. 2 people occupy n seats, he's telling. So 1, 2, 3, 4, 5, 6, 7. How will you keep 2 people in 2 places? 2 factorial. 5 people can be arranged in 5 places in 5 factorial ways. Next. Point number C, 7 persons. 1 person sit in middle. 1 person sit in middle. 1, 2, 3, 4, 5, 6, 7. Take that 1 person and make him sit in middle. 1P1. Balance 6 people can arrange themselves in 6 places in 6P6 space. That is simply 6 factorial. Okay. So I hope this 11th point is clear. All 3 of you. I hope there is no issue in this 11th point. Row arrangement, 7 places, 7 persons. First 3 sit in a particular order, 3 sit in any order. 7 persons, 2 people occupy n seats. 1 person will sit in middle. Yes, sir. Perfect. Next. Example number 12. Now, my dear friends, till now what arrangements we have seen, they are row arrangements. We have seen row arrangements with repetition. We have seen row arrangements without repetitions. Okay. Now, what we'll focus is on, we'll focus on circular arrangements. Circular arrangements. Now, say for example, I am having three things A, B, and C. How will you arrange them in circle? A, B, C. A to B, B to C, C to A. Or A, C, B. Still any other form is there? Circle to form? No, all circles are formed. Don't tell BCA, BCA, CAB, CAB, BAC, BAC, CBA, ACB. So everything is covered here. Okay. If you want to arrange A, B, and C in a circular order, this is the way how will you arrange them in circular order. So n things, if you want to arrange them in circular order, you will arrange them in n minus 1 factorial ways. Okay. Like 7 items are there. You need to form a ring. How will you form a ring with 7 items? It will simply be 7 minus 1 factorial, which is equal to 6 factorial. Okay. I hope that's fine. Yes, sir. Simple. 10 people are there. You need to form a circle with this 10 people. How will you form a circle? Again, same 10 minus 1 factorial, 9. Next. In circular arrangements, if clockwise and anti-clockwise is same, clockwise and anti-clockwise is same. Like I am saying garland arrangement, all these cases. Okay. Or I am telling no two neighbors in same occasion. No two neighbors. No two neighbors in same occasion. In both the cases, what will be the answer? When I am telling clockwise and anti-clockwise is same, either you form them clockwise and anti-clockwise, the answer will remain same. Garland is there. Either you throw like this or you make it reverse and throw. Nobody cares. In this case, my dear friends, we'll be using n minus 1 factorial by 2 ways. Like say for example, I am telling I am having 20 flowers. I am asking you to form a garland. How will you form a garland with 20 flowers? 20 minus 1 factorial by 2. That is 19 factorial by 2 ways. Okay. So I hope the point is clear. Circular arrangements. Basically, it will be n minus 1 factorial. If clockwise and anti-clockwise is same or no two neighbors are together, then in that case, it will be n minus 1 factorial by 2 ways. So what is this nonsense which came in between? Sometimes he'll ask you, like what is the formula if no two things are together? Then you will use no two neighbors are same in no two neighbors in same occasion. Like this, he'll ask formula will be same n minus 1 factorial by 2 ways. One minute. You can see here circular or round table arrangements n minus 1 factorial. Clockwise and anti-clockwise is same. Ring, garland, where no two same neighbors, n minus 1 factorial by 2 ways. Next, circular permutations of r things from n things, npr by r factorial. But basically, we don't have this in our book. No questions we have. However, I'll tell you one question. 10 items are there. You need to take 5 items and form a circle. How will you form? You will form 10p5 divided by 5 factorial. Okay. 10 items are there. You need to take 5 items to form a circle. So it will be 10p5 divided by 5 factorial. No questions you have in your ICA material. Only once I hope in previous year questions they have asked this question. Okay. Circular permutations of r things from n things, npr by r factorial. Like 10 things are there. I need to form a circle using 5 items. Then 10p 5 by 5 factorial. Now see this question, everybody. Question number 13. 6 men are there. You need to form a round table. Point number 8. 6 men are there. You need to form a round table conference. How will you form a round table conference if 6 men are there? Obviously, sir, it is 6 minus 1 factorial, which is 5 factorial. Next, point number B. 6 men are there. 6 women are there. You need to form a round table. How will you form, sir? Again, same. 12 minus 1 factorial, which is 11 factorial. Okay. Next, 6 men are there. 6 women are there. I am telling 6 men are together. Again, how will you form a round table if 6 men are together? 6 men make it to 1 unit. 1 unit. So 1 and 6, total 7 things. How will you arrange 7 things in round table? 7 minus 1 factorial. Next, 6 men can interchange among themselves. Yes, 6 men can interchange among themselves into 6 factorial. So the answer is 6 factorial into 6 factorial. Okay. First, he's telling 6 men are together. Join them 6 men to 1 unit. So total 7 things can be arranged in a round table in 7 minus 1 factorial. 6 women interchange among themselves 6 factorial. Next, point number D. No 2 women are together. No 2 women are together. So when no 2 women are together, what happens? First, arrange the 6 men. 1, 2, 3, 4, 5, 6. How will you arrange the 6 men? 6 factorial ways. Not 6 factorial ways. That's circle, right? So 6 minus 1 factorial ways. In between them, how many gaps are there? 1, 2, 3, 4, 5, 6. In 6 gaps, I arrange 6 women. 6p6. Now don't tell again circle will be formed. Okay, once you make them sit in one place, circle will get broken. Okay, so 5 factorial into 6 factorial. Only in this case, only in first case you will get circle. After that, there won't be any circle. Okay, so I hope all these points are fine. Then never sit together. So all the conditions I hope I have considered. There's no condition what is left. Perfect, Yogita. Let me see if I can get any condition, special condition. Okay, that's it. No special conditions we have other than this in a roundtable conference. Okay, let's proceed to the next one. Point number 14. No, this point number 14 is important one. I'm telling number of arrangements of 10 things taken 4 at a time. Case A. One thing always occurs. One particular thing always occurs. One particular thing never occurs. See what is telling. Number of arrangements of 10 things taken 4 at a time, in which one particular thing always occurs and one particular thing never occurs. That's a given question. Okay. He's telling, first let's look into this. One particular thing never occurs. Like I am telling, 10 students are there. Okay. I need to give 4 chocolates to 10 students. I'm telling one particular thing never occurs. Means for one particular student, I'll never give a chocolate. 10 students are there. In that, for one particular student, I'll never give a chocolate. Means how many students are left? 9 students are there. How will I give 4 chocolates to 9 students? I'll give in 9p4 ways. Okay. So sometimes he'll ask you to write the formula in the examination. Formula will be n minus 1 PR ways. The number of ways of arranging, the number of arrangements of n things taken from r things, in which one particular thing never occurs, is n minus 1 PR. Like 4 chocolates I need to give to 10 students. But for one student, I'll never give a chocolate. So one particular thing never occurs. For one particular student, I'll never give a chocolate. How many are left? Only 9 are left. 4 to 9. 9p4. Okay. Next. He is telling one particular thing always occurs. So 10 students are there. I need to give 4 chocolates. I am telling, pakka for one student, I'll give a chocolate. Dear student, I'll give you a chocolate, don't worry. But from these 4 chocolates, which chocolate I'll give him? So I need to select one chocolate from 4 chocolates. 4C1. For selection, we'll be using C. We'll come across in tomorrow's class. From 4 chocolates, I'll select one chocolate in 4C1. I gave to that kid and I've sent him away. Now, how many chocolates are left? 3 chocolates are left. 3 chocolates I need to give to 9 students. 9p3. So 4 into 9p3. If you want formula, they'll write it as r into n minus 1p r minus 1. Understand this case A once again. One particular thing always occurs history. One particular thing always occurs. For one student, always I'll give him a chocolate. Okay. For that student, I'll always give him a chocolate, no matter what. So from 4 chocolates, I've selected one chocolate in 4C1 ways. I've given to that student. And I said him, go away. Now, how many students are left? 9 students are left. How many chocolates are left? 3 chocolates are left. 3 chocolates to 9 students in 9p3 ways. Okay. So I hope the point is clear. And sometimes he'll ask you to write the formula. You can write the formula and not that important. But the sum is important. Next example. This example, you solve and tell me the answer. 15th one. Think, solve and tell me the answer. 6 plus signs are there. Next, you are having 4 minus signs are there. You need to arrange them in a line so that no 2 minus signs are together. That's your 15th question. Next, 16th question. Number of digits lying between 10 to 1000 formed with 2, 3, 4, 0, 8, 9. This is your 16th question. Think and solve, you'll get, there's no issue. Yeah, that's it. Only two questions, 15th and 16th. I'll give you 5 minutes to solve. Not 5, 4 minutes would be enough. 3 minutes is enough, I hope. Solve this two and tell me the answer. 6 plus signs, 4 minus signs, or no two minus signs are together. So first what I'll do, I'll arrange 6 plus signs. How will you arrange 6 plus signs in 6 places? 6 factorial. In between, how many gaps are there? 1, 2, 3, 4, 5, 6, 7. In 7 gaps, I'll arrange 4 minus signs. 7p, 4. But 6 plus signs are repeated 6 times. 4 minus signs are repeated 4 times. All are same, no? Their repetitions are there. So I divide by number of repetitions. First 6 plus signs can be arranged in 6 factorial ways. In between them, you have 7 gaps. In these 7 gaps, I'll arrange 4 minus signs in 7p4 ways. So 6 factorial cancel. 7p4. 84. 84. 840. Whole divided by 24. Which is 35 ways. Okay. Try to understand that I'm doing. First, I'm arranging 6 plus signs in 6 factorial ways. In between them, we are having 7 gaps. Okay. In these 7 gaps, I'm arranging that 4 minus signs. So 6 factorial into 7p4. Now plus signs are repeated 6 times, so 6 factorial. Minus signs are repeated 4 times, so 4 factorial. 6 factorial, 6 factorial. Cancel 840 by 24. Okay, next. Number of digits lying between 10 and 1000 formed with 2, 3, 4, 0, 8, 9. Okay. 10 to 1000. What are the numbers what we have 10 to 1000? First, I'll say that 2-digit number is possible. Next, 3-digit number is possible. 4-digit number is possible? No, sir. 2-digit number is possible and 3-digit number is possible. So 1, 2, 3, 4, 5, 6. N is equal to 6. R is equals to 2. Do you remember? If 0 is there, how will you form? 0 is there, right? N is equals to 3, sorry. 0 is there, right, my dear friends? How will we take this? I hope you remember. Will be NPR minus N minus 1PR minus 1. Okay. So 6P2 minus 5P1. 6P3 minus 5P2. I'm directly applying the formula. Between 10 and 1000 he's telling, so 2-digit number is possible. 3-digit number is also possible. 6P2 minus 5P1. So what is 6P2? 30 minus 5, 25. 6P3, 120 minus 5P2, 20. 100. So what's the total, my dear friends? Total is 120. Okay. So number of digits lying between 10 and 1000 formed with 2, 3, 4, 0, 8, 9, 25, 100, total 125. Simple? Yes, simple. So that's all regarding permutations. There is some homework questions what you need to solve. You can solve those homework questions, we'll be done with permutations. We'll come back and see if any points are left. Same 10th one is same as 9th point. 10th point and 9th point is same. 10th point I said you number of R things taken from N things is NPR by R factorial. If you want to form a circle. Clockwise and anti-clockwise is same. You'll divide by 2. Okay. Not that important. Next. Number of ways N boys and N girls can be seated in a round table alternative. Just now we have done 6 boys and 6 men and 6 women. That 6 women will not sit together. So you arrange your boys, in between them you arrange your girls. That's the same thing. Next. Number of ways in which n ticks can be equally divided among p, q, r, where p plus q plus r is equals to n. We'll do this when we do combination. Then it will be more clear. Okay. When we do in terms of combination, the concept will be more clear. Next, fourth and fifth result. NPR by NPR minus 1 will be n minus r plus 1. Like say for example, I am saying 10p5 divided by 10p4. What will be 10p5 by 10p4? What is 10p5? 10 into 9 into 8 into 7 into 6. 10p4, 10 into 9 into 8 into 7. Cancel. What is left? 6 is left. Instead, is telling n minus r plus 1. 10 minus 5 plus 1, it will also give you 6. Okay. Just a formula which you can remember. Next. He is telling NPR plus R into NPR minus 1 is N plus 1 PR. Okay. NPR. This R is not on the top. This R is not here. Rather, this R is here. Okay. I'm telling NPR. Let's take 5P3 plus 3 into 5P2. Let's check what we'll get. 5P3. In exam also, you can check with the options like this. You need not derive that. Okay. What is 5P3? 5 into 4 into 3. 60 plus 3 into 5 into 4. 3 into 5 into 4. Which is 60, which is equals to 120. It's telling n plus 1 PR. What is 5 plus 1? 6 P3. 6 into 5 into. It's also same 120. Okay. In the exam also, you can just take some random numbers and you can check whether it is satisfying. Okay. So I hope all these points are clear. Now, before proceeding further, 3-4 sums are there. I want you to solve now. Once solve them, tell me answers, then we'll proceed to combination. Okay. 17th one. After these are done, we can then go to combinations. Numbers less than 1000 divisible by 5. With 0, 1, 2, so on till 9. 18th one. One, 2, 3, 4, 5, 6, 7 form 4-digit number greater than 3400. Next, 19th one. They did tricky questions, but please try them. So don't worry, I'll explain them. Numbers greater than million formed with 1 0, 2 ones, 1 3, 3 sevens. Little tricky, but please try them. Yeah, that's 17, 18, 19. I'll give you 5 minutes. Try them. Little tricky they are, but you have to get it. Okay, 19th one, let me check. Some of you have given the answers. He's telling 1 0, 2 1s, 1 3, 3 7s. 1, 2, 3, 4, 5, 6, 7. In a million, how many numbers are there? Ones, tens, hundreds, thousands, tens, lakhs, 10 lakhs. 10 lakhs makes 1 million. So you need to form a 7-digit number. N is equals to 1, 2, 3, 4, 5, 6, 7. R is equal to 7. You need to form a 7-digit number. If 0 is there, how will you do? NPR minus N minus 1P R minus 1. Right? So 7P7 minus 6P6 whole divided by 1 is repeated 2 times, 7 is repeated 3 times. So 7P7, 7 into 6 into 5 into 4 into 3 into 2. 5040 minus 6P6, 720 whole divided by 2 factorial, 3 factorial. So 5040 minus 720 whole divided by 12. Answer is 360. Okay. I hope that's fine. If you don't like this, you can do it another way also. There is no issue. 1, 2, 3. This is more simple way than any other way. If you want other way also, I can teach you. See here. 7-digit number 1, 2, 3, 4, 5, 6, 7. Right? 0 can't be in the first place. 1, 2, 3, 4, 5, 6. 6 numbers. Any one number can be in the first place. 6p1 base. Okay. Now from 7 numbers, 1 number is completed. How many numbers are left? 6 numbers. 6 numbers can be kept in 6 places in 6p6 base. 1 is repeated 2 times, 7 is repeated 3 times. So 6 into 6 factorial by 12. 720 into 6 whole divided by 12. You will get the same 360. Anyway, your answer is same. Okay, either you use formula or you do without formula. Answer is C. Okay. So I hope you got it, Vaishnavi, where you went wrong. Yogita will check. 7p6 minus 6p5. No. 7p7 minus 6p6 divided by repetition is there. So you have to divide by number of repetitions also, Geeta. Next. Let's do the 17th one. Numbers less than 1000. She took number of zeros as R. Okay. Fine. There's no issue. Numbers less than 1000 divisible by 5. What are numbers less than 1000? You can have 3-digit number. You can have 2-digit number. Or you can have 1-digit number also. 3-digit number is still divisible by 5. When can you say that they are divisible by 5? First, last number 0 or last number 5. I want a 3-digit number. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Last number 0. Take this 0 and place here. How will you keep one number in one place? 1p1. Balance 9 numbers are left. 9 numbers can be kept in two places in 9p2 ways. So 9 into 8, 70. Now last number 5. Take this 5 and keep here 1p1. Can you keep 0 in the first place? No, 0 can't be kept in the first place. For this first place, you can't keep 0. So 1, 2, 3, 4, 5, 6, 7, 8. 8p1. Now, my dear friends, total 10 numbers are there. First number has taken its position. Last number has also taken its position. So 8 numbers are left. How will you keep in middle place? 8p1. So 64. So numbers less than 1000. First three-digit number. I took last number 0. Next, I took last number 5. When I took last number 0, I got 72 base because last number I kept in last place. 9 numbers I can keep in first two places in 92 ways. One minute. Next, last number 5. When it is last number 5, first I kept the last number. Now in first place you can't keep 0. So 5 is gone, 0 is gone. 8 numbers I can keep in the first place. Now for the middle place, 10 numbers, 2 numbers have taken their position. So 8 numbers are. Little tricky, but I hope you are in a position to digest it. Next. B. Numbers less than 2 distant number. First, last number 0. Last number 5. Two distant numbers are not distant. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now last number 0. Take this number and place here. 1p1 place. 9 numbers can be arranged in 9p1 place. Now last number 5. Take this 5 and place here. 1p1 place. Now 0 can obviously not be placed in the first place. 1, 2, 3, 4, 5, 6, 7, 8. 8p1. Now one distant number. I hope there is only one distant number which is divisible by 5. There is only single one distant number which is divisible by 5. That is 5. So 72, 64, 9, 8, 1. What is the answer? 72 plus 64 plus 9 plus 8 plus 1. Answer is 154. Okay. 1 minute. Let me check the answer. Yes, sir. It's 154 is the answer. A little bit tricky, but I hope you can take that. I hope Yogita, that's fine. And I hope Vaishnavi, that's also fine. 154. Yeah. First numbers less than 1000 must be formed. So you can have a 3 distant number or 2 distant number or 1 distant number. See, 1 distant number is simple. There is only one distant number in this word which is divisible by 5, and that is 5. So this is simple, I hope. Now I want 2 distant numbers. First, what I am taking, last digit 0. Take this 0 and place here. So how many numbers are left? 9 numbers can be placed here in 9p1. So 1p1 into 9p1, which is 5. Last number 5. Take this 5 and place here in 1p1 place. 0 can't be placed. So 1, 2, 3, 4, 5, 6, 7, 8 can be placed here in 8p1. So answer is 8. So 9 and 8. So 2 distant number is clear. I hope simple 2 distant number. So I hope 1 distant number is clear, and I hope 2 distant number is also clear. Next, 3 distant number, last number 0. Take 0 and keep here 1p 1 ways. Now 9 numbers are left, can be kept in 2 places in 9p 2 ways 72. So I hope this is also clear, there is no issue. Now last number 5. This here some issue you may have. Take this 5 and place here in 1p 1 ways. Now since 0 can't be in the first place, 1 2 3 4 5 6 7 8, take them 8 numbers and place here in 8p 1 ways. Okay. Now how many is there? 10 numbers, 2 numbers have taken their position. So 8 numbers are left. 8 numbers should place here in 8p 1 place, which is 60, 72, 64, 9, 8, 1. Total 154. I hope that's fine. Next. Now, see this. 1, 2, 3, 4, 5, 6, 7 form 4 distant numbers greater than 3400. Form a 4 distant number greater than 3400. Fine. Can the number start with 1? No, sir. Can the number start with 2? No, sir. Can the number start with 3? Yes. Starting with 3. Take this 3 and place here 1p1. Now, can you place 1 here? No, sir. If you place 1 there, it will be 3100. 3100 is less than 3400. Can I place 2 here? No, sir. It will be 3200. 3200 is still less than 3400. So 4, 5, 6, 7. Any one number from these 4 numbers can be placed here. 4p1. So from total 7 numbers, 2 numbers have taken their position. So how many numbers are left? 5 numbers are left. 5 numbers can be arranged here in 5p 2 days. So 4 into 20, 80. This is starting with 3. See, this problem arises only when it is starting with 3. Okay? Because if it is starting with 4, 5, 6, 7, this type of issue will not occur. Because 4, 5, 6, 7, 4,000, 5,000, 6,000, 7,000 are always greater than 3,400. From 4, 5, 6, 7, any one number can be placed here. 4p1. Now total 7 numbers are there. 1 number has taken its position. So 6 numbers are there. 6 numbers can be placed here in 6p3. So 6 into 5 into 4 into 3. 360. So what is 360 plus 80? 400. Okay. So I hope that's fine, everybody. Number of numbers greater than 3400. First, I'm telling it is starting with 4. It is starting with, so first I'm telling it's starting with 3. 3 I took and I kept there. Next, 1, 2 cannot be kept in second place. So only 4, 5, 6, 7 can be kept in second place. So for 4 numbers, I'll take 1 number to keep in the second place, 4p1. Now, from 1, 2, 3, 4, 5, 6, 7, from 7 numbers, 2 numbers are completed. 5 numbers are left, can be kept in 2 places and 5p2 ways. So total 4 into 20, 80. Next, the same thing with 4, 5, 6, 7. It is not that difficult because 4, 5, 6, 7 are always greater than 3000. So 360 plus 80 is equals to 440. So I hope that's fine, all 3 of you. Little difficult questions.